Hello, friends. Today, we will begin our journey with Material Studio. This is our first class, and we'll start from the basics and gradually move towards more advanced concepts. As you may know, Material Studio is a powerful software tool used in material science and engineering applications. It provides a comprehensive platform for simulating and modeling the behavior of materials across various scales, from atomic to microscopic. Material Studio offers several key features, including molecular modeling and simulation, material properties prediction, crystal structure analysis, phase diagram calculation, and nanoscale materials modeling. The software is widely used in fields such as material science and engineering, chemistry, chemical engineering, physics, nanotechnology, biomedical engineering, and energy and environmental research. The benefits of using Material Studio include the discovery and design of new materials, improved understanding of material behavior, and the enhancement of material properties. There are many modules within Material Studio, such as Castep, DMOL 3, Foresight, and many others. For example, with Castep, we can predict properties like electronic properties, structural properties, and the optical response of materials. We will discuss each of these in detail in upcoming lectures. Now, if you look at the screen, you will see the structure of titanium dioxide. This structure is available in the Material Studio library. Some structures are readily available, while others may need to be built for specific calculations. Building structures in Material Studio is quite easy, which is one of its great features. When building a structure, we need to know the material's lattice constants, space group, positions, and other parameters. We can also easily create layered structures, heterostructures, heterojunctions, and more. Let's now learn how to import a structure and start a calculation. First, click on the file icon in the top right corner, then click on Import. Here, you will find a variety of structures such as ceramics, metals, metal oxides, nanotubes, polymers, and more. Since we are interested in titanium dioxide, we will click on metal oxides and select it. You can see the structure we selected on the screen. Next, we will set the display mode. There are several options, like stick mode, ball and stick mode, and CPK mode. We will use the ball and stick mode and adjust the size of the sticks and balls to fit the screen. Now, let's label the structure. The brown color represents titanium atoms, and the red color represents oxygen atoms. We also have a few explorers, like Job Explorer, Project Explorer, and Properties Explorer. By examining the symmetry, we can see the arrangement of the titanium and oxygen atoms. Now, let's move on to the calculations. First, we'll perform a geometry optimization. To do this, go to the Modules menu and select the Castep tool. Set the task, quality, and approximation. We'll set the quality to medium and use the GGA functional with the PBE approximation. We will perform calculations for all functions to determine the minimum energy. Next, we'll configure other settings, such as the algorithm. The best algorithm for this is BFGS, and we'll set the stress to 0. For the electronic setup, we'll configure SCF, K-point, pseudopotential, and other parameters. We also have the option to manually adjust the energy settings. We will go over these steps in detail in later lectures. Now, let's set up the properties and job control. We will allocate all cores to run the job in parallel. Once everything is set, run the job. After running the job, you have the option to choose between running with a primitive cell or a conventional cell. We'll start with P1 symmetry. After a short time, you will see that our calculations have successfully completed. Let's review our input and output structures and analyze the results. Keep in mind that this is just a rough calculation. For more accurate results, each setting must be configured precisely, which we will cover in upcoming lectures. Thank you for your attention, and be sure to subscribe for more videos.